9, Section 1 in Math Analysis. We're going to be doing polar coordinates today. That's quite enough of that. Okay, so throughout your entire mathematical education, you have viewed a coordinate system as what we call a rectangular coordinate system or a Cartesian coordinate system. Basically, any point, any location that you want to specify for a point would be the number of spaces horizontally and the number of spaces vertically from some origin. Today, all that changes. Okay, instead of identifying a point as a certain number of spaces right or left or up or down from a center point, we're going to identify it as a certain distance away from the center at a certain angle. And that's called polar coordinates. So, let's check out some graph paper. Okay. Ah, wrong. Got take two. Okay. As I said before, these are kind of annoying interruptions in this show. Okay, this is graph paper. You thought graph paper had vertical and horizontal lines on it, but now you realize it doesn't. Polar graph paper. Okay, so this is, wrong, okay. This is 0 degrees, and notice this is 90 up here, so this would be 15 degrees, 30 degrees, 45 degrees, 60 degrees, 75 degrees, 90 degrees, and so on all the way around here. So let's just go 105, 120, 135, 150, 165, 180, oops, we're not at 200 yet. We're at 195, 215, 230, something has gone awry. 180, 195. Oops. Yeah, that wasn't 215. Cut take two. This be take three. All right, 195, 210, 225, 240, 255, 270. Let's just keep going. So we've got 300, 315, 330, and 360. Okay, so yeah, we can fill these in. So this would be 285, and this is 345. So we see that we've got angles every 15 degrees. Now, each circle is 1 unit. So if I wanted to identify the point, let's say 3 30 degrees. That would be the 30-degree line, 1, 2, 3. So there's the point 3 30 degrees. We'll put that here, 3 30 degrees. Now, if I wanted to show the point, let's say 4 negative 30 degrees. So here would be 1, 2, 3, 4 in the negative 30 degree direction. There's 4 at negative 30 degrees. Now, clearly you can see that we could also have named this angle 4 at 330. So 4 at negative 30 or 4 at 330 is the same thing. Now, what about I take the 45-degree angle, but I want to go the opposite direction. So 45, if I want to go, let's go 2 in the negative direction of the 45-degree angle. So here is, this is negative 2 in the 45-degree direction. Notice 45 is going that way. That's the positive direction toward the number 45. Well, the negative direction is going to be back the opposite way. So there's negative 2, 45. Now, also, I could have named this point 2 at 225. Or, I also could have named it 2 at negative 90, negative 120. Let's see. Yeah, 2, yeah, here we are. Negative 135. So 2 at negative 135. Let's just make sure we know which point we're talking about. 2 at negative 135 is right there. So notice we can name these points with a positive magnitude, a positive angle, a positive magnitude, a negative angle, a negative magnitude, a negative angle, or a negative magnitude and a positive angle, and now a negative negative. How do we name this with a negative magnitude, negative angle? Okay, what we do is we say, what's this angle if we name that as a negative angle? Well, if I'm going around this way, then this would be negative 180, negative 270, negative 315. So, I'm going to talk about this point right here as negative 2 at negative 315. So notice I've got positive, 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 negative, negative, positive, negative, negative, all to identify the same point. All right, so let's recap the action here. You can name any angle from 0 to 360 in the positive direction. We could name that same angle from 0 to negative 360 going the opposite direction. So any angle I want to name, I could name it positive going counterclockwise or negative going clockwise. Now, any magnitude, I could name it positive in the direction of the angle. So notice this is positive 3 because it's going in the direction of the 30-degree angle. Or I could name it negative going in the opposite direction of the angle. So instead of going toward the 45, it's going away from the 45, which makes it negative 2 at 45 degrees. Or negative 2 at the negative 315. Or we could say it's positive 2 going at the positive 225 degree angle. Or it's positive 2 going at the negative 135 degree angle. So we can name any point between negative 360 and positive 360 degrees in either positive, 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 negative, negative, positive, negative, negative. Okay, so let's try another one. I'm going to put a point on here, and you're going to name it 4 different ways. Let's see. Let's go with this point right here. Okay. So what I want you to do is name that point 4 different ways. So first we'll go the easiest way, and that'd be positive, positive. So what is this? It's 6 away at 120 degrees. There's our positive, positive. Now, let's name it positive, negative. So 6 away at, what's our angle if we go negative? Well, if I go clockwise here, this would be negative 180, negative 210, negative 240. Okay, so that's positive, negative. Now, let's name this negative 6 at a positive angle. So the question is, if we're going to name this negative 6, it must be going away from the angle down here. So it's going away from the 300 degree angle. So it's negative 6 at 300 degrees. Then, if I want to name it negative, negative, it's going to be negative 6 going away from this angle negative, which would be negative 60. That's it. There are your 4 angles. Okay, so that's the first skill you have to master, is taking any point and being able to name it 4 different ways. Now, the next thing you might suspect here is that we're not only going to be naming these in terms of magnitude and degrees, but we're going to be naming them as in terms of magnitude and radians. Oh yeah! Magnitude and radians. Yes, we love radians. So, let's name our radians. You guys know your radians. Here's pi over 6. Here's pi over 3. Here's pi over 2. Here's 2 pi over 3. Here's, oh, we forgot pi over 4. What the heck? Forgot pi over 4. And then we've got 3 pi over 4. We've got 5 pi over 6. We've got pi. We've got 7 pi over 6. We've got 5 pi over 4. We've got 4 pi over 3. We've got 3 pi over 2. Then 300 degrees is going to be 5 pi over 3. 315 gives us our pi over 4, so that's going to be 7 pi over 4. Then 11 pi over 6 for the 300, and back to 2 pi or 0. Now, the in-between is going to be pi over 12s. So 15 degrees would be pi over 12. There's 2 pi over 12, 3 pi over 12, 4 pi over 12, 5 pi over 12, 6 pi over 12, 7 pi over 12, 8, 9, 10, 11 pi over 12, 12 pi over 12, 13 pi over 12, 14, 15, 16, 17 pi over 12, 18 pi over 12, which is 3 pi over 2, 19 pi over 12, 20 pi over 12, 21, 22, 23 pi over 12, and last we have 24 pi over 12, or 2 pi, back to 0. Okay, so now we can name these angles in terms of r theta so rather than x, y, we're going to be naming it r theta, and the r will be the distance from the origin, and theta will be the angle, either in degrees or radians. We're fluent in both languages. Okay. Cruising onward, we're going to be now graphing really simple polar equations. So let's check out, I'll leave this here. So we're going to graph the equation theta equals pi over 4. What's theta equal pi over 4 look like? It looks like a line, nice, that goes toward pi over 4. And notice it goes the other direction too, because any line contains the positive or the negative. So there's my line, theta equals pi over 4. It's in the direction of pi over 4, both toward it and away from it. So piece of cake. So you can see that the rectangular form of that function would be just y equals x. But now it becomes theta equals pi over 4. So that's fabulous. All right, now, the next type of function we're going to deal with will not be linear. This function is just going to be r equals, let's say, 2. R equals 2. What's that function going to look like? Well, it looks like a radius of 2. Yeah, that's a perfect circle. If it appears to be flat anywhere, it's just the air density variations, of course. Okay, so this is r equals 2. Yeah, probably the camera. It's the camera's fault that it doesn't look like a circle. Okay, this is r equals 2. It's basically, if I was going to give you the line y equals 5, what's y equal 5 look like? Well, it looks like a horizontal line at y equals 5. X is anything, y is 5. Same thing here. What's r equal 2 look like? Well, radius is 2, the angle is anything we want. Or, like when we did the theta equals pi over 4, it's theta is pi over 4 and the magnitude is anything. Okay, so those are two really simple functions. The last thing we're going to do in this section is determine the distance between 2 points. You guys have a distance formula for rectangular coordinates. Now we're going to do a distance formula for polar coordinates. So let's just say we've got these 2 points. Go with this point and this point. So what are these points? Well, let's label them in terms of radians. It really doesn't matter. So this point is 5 at pi over 6. And this point is 3 at 5 pi over 3. And what we want to know is, what's the distance between these 2 points? basically what we have here is a triangle that's not a right triangle. So our triangle looks like this. Okay, so clearly this side is 5, this side is 3. What's that angle? Well, it's going to be 5 pi over 3 minus pi over 6. So that's 10 pi over 6. Oh, I made it a 90-degree angle. Okay, well, we'll just go with that then. So 5 pi over 3 is 10 pi over 6 minus pi over 6 makes it 9 pi over 6, or 3 pi over 2 is the angle here. But really the simplest way to do it is just say that from here down to here, this angle inside is pi over 2. Yeah, we'll just put this in red. Pi over 2. Okay, so now we have a triangle where we know the length of two sides with the angle in between. How do we get the third leg? I know you're all saying law of cosines, this is so easy. Why would he even pause that long? Yes, it is law of cosines. You're right. So go ahead and do that. Law of cosines. What, you forgot? Okay, here we are. Let's make some room here. Okay, law of cosine says that the distance is going to be the square root of the first side squared plus the second side squared. Oops, that's a 3. Minus 2ab cosine of the angle in between. So notice cosine pi over 2 is 0, so this thing just ends up being the square root of 5 squared plus 3 squared, which is 25, and 9 is 34, so this ends up being d equals square root of 34. So the general formula for the distance between 2 points is going to be distance between point 1 and point 2 equals the square root of the, how do we say, yeah, r sub 1, which is how far away point 1 is, squared, plus r sub 2, which is how far away point 2 is, square that puppy, minus 2 r sub 1, r sub 2, there's my 2ab, cosine of the angle in between. Well, what's the angle in between? It's going to be the angle, it's going to be theta 1 minus theta 2. That's it. Now, keep in mind that it doesn't matter what order you put the angles in, because if you go theta 2 minus theta 1, that would just be the negative of this. And you all remember that cosine is an even function, which means cosine of negative theta equals cosine of theta. So that's completely, it completely doesn't matter what order the angles are in. So you just take your first radius, square it, second radius, square it. There we have 5 squared plus 3 squared minus 2 times 5 times 3 times cosine of the angle in between. So that's it. Let's try one more example that actually doesn't turn out to be a 90-degree angle. Let's see here. Yeah, we'll go with degrees this time too. Okay, so our first point we're going to say is, yeah, we'll go with 4 at 15 degrees. So here's 4 at 15 degrees. And then we'll do, now let's do another quadrant. Okay, so we'll go out here, make it 5 at, what is this, 150. Okay, so what I want to know is, what's the distance between these 2 points? So this distance is going to be square root of 5 squared plus 4 squared minus 2 times 5 times 4 times cosine of the angle in between. Well, what's in between 150 and 15? Yeah, 135. Okay, so this ends up being 25. Yeah, it's time to crank it out in the calculator because we want a distance in decimal. So you know the square root of 135 is going to be negative square root of 2 over 2, which is going to be about negative 0.707. But let's go ahead and crank this out. So we've got 25 plus 16 minus 2 times 5 times 4, which is 40. So 40, enter 135, cosine, make sure you're in radians, it should come out negative 0.707. Multiply that. Now notice we're subtracting a negative, so that ends up adding, so it ends up being 69.284 inside the square root, and when I take square root of the whole thing, it ends up being 8.3237. 8.32 is the distance. Now, as always, you want to make sure that that makes sense. Does this line look like it's 8.32 when the distance from here to here is 1? Of course it does. All right, so that's it. Game over. Have fun with these.